Now let's go ahead and graph this one. So to graph y equals secant 2x plus pi halves minus 2, you're going to graph the cosine graph. Everything is going to be the same because these two graphs have some things in common. And so cosine 2x plus pi halves minus 2. All right, so they're reciprocals of one another, and we can use cosine to help us graph secant. All right, so now if we're graphing cosine, we need to find a few things. We need to find the amplitude, and amplitude is found by looking at the coefficient in front of cosine. All right, so there's no number there in front of cosine, so that means the amplitude is 1. All right, now let's find the period. All right, so the period for cosine is 2 pi divided by b. B is the coefficient on x, so it's that coefficient right there. So since b is 2, the period is going to be 2 pi divided by 2, or just pi. All right, and let's start with that, and then we'll find a few more things. All right, so we start off with our key x and y values for, let's see, I don't think I have enough columns here. Let's see, I need, we will have a period change. We will have a phase. Oh, nope, I don't have enough. That's okay. I'll just draw an extra column. All right, so we start off with our key values, and our key x values are those quadrantal angles, 0, pi halves, pi, 3 pi halves, and 2 pi. The y values that go with that for cosine, cosine starts at its max, and then x-intercept, min, x-intercept, and max. All right, and so now there's no amplitude change, right? So we don't have to multiply y by anything, but we do have a period change. So to find our new values based on the period change, you take the period and divide by 4. So that would be pi fourths. That means we still start at 0, but instead of going up by pi halves like we have on the x's there, we're going to go up by only pi fourths, because this graph is going to finish one period twice as quickly. It's going to finish it in pi. So we have 0, we have pi fourths, then we have 2 pi fourths, which is the same as pi halves, and then 3 pi fourths. Right? So you see all of these values are half as much as the original period for cosine. Oops, let me see if I can, oh, darn it. Let me undo that. So you really can't move things, so I hope you can read that okay. It's pi fourths, 2 pi fourths, 3 pi fourths, and pi. I could maybe rewrite that bottom too a little bit nicer, just because there's just not quite enough space. 2 pi fourths, 3 pi fourths, and pi. There we go. All right, and so we have our x values, our period change. There's one other thing that occurs with x, and that is a phase shift. All right, so you can either factor out the 2, or if you prefer, you can just set that whole parentheses equal to 0 and solve for your phase shift. So 2x plus pi halves equals 0, right? Because we would start off on the y-axis, right? But we've been shifted. All right, so we want to isolate x, so we'll subtract pi halves from both sides. So 2x equals negative pi halves, and then divide by 2. And of course, dividing by 2 is the same as multiplying by a half. So that means x is negative pi fourths. So that means that this graph is shifted pi fourths left. All right, so we're going to subtract pi fourths. All right, so 0 minus pi fourths is a negative pi fourths. And then pi fourths minus pi fourths would be 0. Pi halves, so 2 pi fourths minus pi fourths would be pi fourths. And so notice they're going up by pi-fourths because that's exactly what our period values went up by. 3 pi-fourths minus pi-fourths is 2 pi-fourths, or pi-halves. And then pi, which is 4 pi-fourths, minus pi-fourths would be 3 pi-fourths. Right, so if you don't like subtracting, once you find your first value, you can just count up by the exact same values you counted up by for the period change. And we have one more thing for y, but I don't have enough space. So I'm going to try to move this over a little bit so I can get one more column in there. There we go. All right, so our graph here is we have a vertical shift. All right, so we've been shifted down to. All right, so we're just going to subtract 2 from all the y values. So this is the vertical shift. All right, so 1 minus 2 would be a -1. 0 minus 2 is a -2. -1 minus 2 is a -3. 0 minus 2 is -2, and 1 minus 2 is -1. All right, so this is our new x values. The final thing that happened to x was the phase shift. And the final y values are the vertical shift, if we can get around those values there. So we're going to go ahead and graph those values. I'm going to have each, pi-fourths is fine. So each line will be worth pi-fourths. So this would be pi-halves, and this would be pi. And maybe we'll do 2 periods. So this would be 3 pi-halves, and this would be 2 pi. All right, so we'll go ahead and graph our values. So we've got, oh, and then we're shifted, so I better put some values over here. This would be negative pi-halves. All right, so each line is worth a fourth, and this would be fine. We don't need to change these values at all. So each one is worth 1. All right, so we'll go ahead and graph. So negative pi-fourths, -1. Oh, you know what? Let me also graph the, usually I like to graph the midline value, but maybe I'll leave the midline out of this one, just so there isn't so many lines. All right, so our midline, just remember, is going to be at -2. So we're oscillating right there around -2. I won't draw that line in, I guess. All right, so we have negative pi-fourths, -1, which is right there. We have 0, -2, which would be right here. And then pi-fourths, -3 would be right here. And then 2 pi-fourths, or excuse me, yeah, am I looking at the right value? Yes, I am. So 2 pi-fourths, which is the same as pi-halves, -2, right? So I'm just looking right here and here. And so 2 pi-fourths, and right there. And then 3 pi-fourths, -1, right? So that would be right here. So each one of these lines is worth, going across, is worth a fourth. And notice our graph has been shifted down too. So here, 1 period. If we wanted to do one more period, we would just repeat the pattern. All right, so then the next point would be here, and then here. Got to hit the right spots, and here. All right, let's see if I can get through without, I'm a little off, just because my orientation's a little off. But there we have 2 periods of our graph. All right, so this is 1 period right here, and then this is another period. All right. So now we want to graph secant. So to graph secant, that's all right, green, we need to find our vertical asymptotes. So the vertical asymptotes are where cosine, the graph of cosine, either has x-intercepts if it's not shifted, or points on the midline. Because those values were x-intercepts, and then we shifted it down to. Because if you notice, our graph doesn't even cross the x-axis, right? But these points that are, actually maybe we'll draw this in, the points, anything here on this midline was an x-intercept before we shifted it down. All right, so those are still going to be x-intercepts, or excuse me, vertical asymptotes for our graph. I'm going to draw in some other color here. Here we go. There's still going to be vertical asymptotes for the graph of secant. So we have vertical asymptotes at x equals 0, x equals pi halves, and x equals pi and 3 pi halves, and so forth. We have, since we have 2 periods here, we have more vertical asymptotes, but actually there'll be a vertical asymptote every pi halves. All right, so there happens to be 3 on this graph. And there's an infinite number, and they're going to occur every pi halves. So let's go ahead and we'll draw those in. Here's one vertical asymptote, and then here's another vertical asymptote. So actually having that midline in, actually it turned out to be pretty helpful because it helps you see where your vertical asymptotes are going to be. They're going to be wherever your graph of cosine, or if we were graphing cosecant, wherever your graph of cosine intersects that midline. If there's no vertical shift, the midline is the x-axis. If there's a shift, then the midline shifts too. So there is all our vertical asymptotes. And then the next thing we do is it has the same points, same max and min points as cosine does. Of course, it's just a little bit reversed. So what's a max for cosine ends up being a min for secant. And what's a minimum for secant, well, there's not a lot of space here, ends up being a maximum for secant. I'm kind of sorry I put those red lines in there showing you one period, because now my graph is right in the middle of the way. So I don't really need this, so I'm going to get rid of it. I was just showing you, whoops, one period and the next period. It's not part of the graph. Let's go ahead and graph the rest. All right, so here, that maximum value is a minimum value, got lots of space here, for the secant graph. This minimum value is a maximum value for the secant graph, and likewise, that point there is a minimum value, right? And it just is going to keep repeating that pattern. Let's go ahead and do domain and range, and then we have finished. So you see, all you do to graph secant or cosecant is for secant, you graph the cosine curve. For cosecant, you graph the sine curve, where the graph has either x-intercepts or points on the midline, if the graph's been shifted. That's where there's vertical asymptotes. And then they share points, the max and min values, with the graph of cosine for secant and sine for cosecant, respectively. And so let's go ahead and do domain and range. I have no idea where I'm going to squeeze it in, but I guess maybe here. So the domain, all right, so notice we have a vertical asymptote. They went up by every pi halves. So our domain, actually I'm going to write it like this, is going to be all real numbers except multiples of pi halves. And I'm just going to write right over the words. I wonder if I can get rid of them. Oh, I can. Goodbye. We've seen them enough. There we go. Oh, look at all the space I have. Wow. Except multiples of pi halves. And then the range, right? So there's just not going to be any points between -3, because we're shifted down. So that this point right here is at this point right here, where my pen is going. That point right there is -3. All right. So there's nothing between -3 and this point right here, that min value, -1. So our range is -infinity, and then we stop at -3. And we do go through -3, so it gets a bracket. And then we pick up again at -1, and then we keep continuing. And that's it. That's all the steps, right? So now you can go graph secant and cosecant. Thanks for watching. Bye for now.